The classwork we are doing together is mostly to show you how much R is efficient in doing mathematical operations on a table. As you experience it and as you hopefully have done it, you notice that very easily you can deduct a fixed number from all elements of a column and divide it by a number to get it normalized. To finish the normalization project that we have according to the classwork, we need to repeat these things with index 2 and also index 3. And after that, we have it. It was an example of manipulation of a table to show you how much powerful R is in this regard. Please, my friends, do not get intimidated by the formula, because the formula is something that you are given the formula. You just need to know how to do these things, and we are going to do many of such practices, so you will find yourself in control when you are working with R. Now, if we want to continue this and do it for the second input column, I'm going to copy and paste it. So here everything is the same, just instead of index 1 we will have index 2, and I run this FTO, and after that we can check FTO, and you see index 2 is also normalized now, and all the elements are between 0 and 1. The same thing goes with the last one that I expect you are gonna finish it yourself and check the answer with the next slide to make sure you have done it correctly. If you have any questions regarding these calculations, please do not hesitate in reaching out to me and we can discuss all the points with each other. And also, since the video is recorded, you can replay it as many times as needed. Also, one delicate point that you notice after doing this classwork, you notice that when you have a CSV file that you read it into R, in fact, you are having a data frame. And when you are doing some sort of manipulation on the data frame that you have, as you can see here, and when you do the manipulation side like this, that you deduct the minimum number of that column and divide it by another number, the outcome is still a data frame. And also, this is the data frame as well. And also, I'm going to show you in R to check the structure of the data frame and to see what will happen. Here we have FTO, and when I run it, you can see these two things are normalized. And now we are gonna check the structure of FTO, and we expect it to be still a data frame. So str FTO, I run it, and as you can see, str FTO, it says here data frame. It says that 400 observations, that's correct. And here are the numbers and the values inside the table. Now you should be good with practical features of a data frame, and now we are going to its explanation in more academic way. Okay, data frame, as we discussed it before, it says a table, finish, or a two-dimensional array-like structure in which each column contains values of one variable. We notice that index 1, index 2, index 3 were input column, and each row contains one set of values from each column. Now you are completely familiar with this structure. Another thing, there are some points. It says following are the characteristics of a data frame. the column names should be non-empty. And as for example, for this one, since we decided to have header, so they have names, and even if we had chosen header false, R automatically assigns names to them. The row names should be unique, okay? The data stored in a data frame can be of numeric, factor, or character type. Each column should contain same number of data items. That in future we are going to learn about these things more, and that's the reason before we read these specifications and characteristics, we worked with data frame, because according to my experience, it always works better. But here, for example, when I say each column should contain same number of data items, it is obvious, because as you can see, it starts from 1 and it ends to 400. So it is very obvious type of point that it says each column should contain same number of data items, because it is not possible that one column has, for example, 300 rows and the other one has 400 rows. In a regular situation, when we want to do a table, all the columns have the same number of rows. Okay, now you learned how to create a data frame. What was that? Importing a CSV file into R, and it would give us a data frame. Is there any other way to create data frame inside R, like the ones we learn with vectors, like the ones we learn with lists, like the ones we learn with matrices? Yes, we have such a things. The name of the function is data frame function. And again, you noticed how much this language has a high level. It is very close to human way of communication. Data frame creates data frames and works similar to matrix function. What is the syntax? Here we put data frame, and we are going to do practices on this, my friends. The best way to learn is doing practices, but here you can see the general description. Okay, so now we know when we want to create a data frame, we use this function, and after that we have something here. Now, according to your general knowledge of R you have got so far, you may come up with some explanation for these things. For example, when you want to create a data frame, you know that you put data.frame, and here it says that these arguments are of either the form value or tag equal value. Tag equal value, you have been familiar, you got explanation with the concept, with the list. If you remember, tag equal value, or even you can put the values without any tag. And about the row names, it's the name of the rows, and it is up to you. You want to put something or you want to leave it null. And about the strings as factors, true, and so the other one is false. But it says that, do you want to consider strings as factor, or no, you just want to leave them as strings? For example, we have talked about these things. If now I'm gonna show you the slide related to factor so you can retrieve more. See here, I bring for you the slide from last session, SI 6. So in that session, we talked about factor in R. For example, we had this: when we factor these things, it goes for only the different ones. And for example, here, when you get the levels, it says that 1.23, 5.56, and 7.44 4. As you can see, it doesn't repeat them because they are considered at level. And now here in that thing that I just showed you, it says strings as factors. It says that, do you want me to automatically apply factor command to the string columns or not? Remember, my friends, we have discussed on this page before. If you need more explanation on that, you can refer to that PowerPoint that I just told you. It belongs to the previous session of R, that was SI6. And even if you have more questions, you can reach out to me. So that's the general rule about programming, that when you always keep caught up, you can have very smooth and easy type of learning, because many of the things repeat themselves like this: strings as factors, true. And now we are going to do some examples together to see how these things work. We are going to start it very simple together to see how it works. Okay, we start simple like this. We are going to create a data frame, and we are not going to use tag value. So we are going to just put data frame, and we are going to put some values here, okay, without anything else. See, my friends, how much it is practical. Don't feel confused. Don't feel intimidated by the things that you are learning. Always try your best to stay in control of the things that you are doing. See, now we have a page about data frame, okay? Many of the things on this page are just repetition of the things that we have discussed before, like strings as factor, just in a different shape. Row names null, okay? So even in this situation, you can ignore all of the things and you do it in your way. I'm going to do it in this way, data.frame, and I'm just going to put some values over here. For example, let's go and make a data frame of size 3 rows and 4 columns. Just one point, my friend, before we go to R. Since we want to start it very simple, we are not going to put any tag over there, and we are going to just put value, okay? But according to the previous slide, you remember that it says each column names should be non-empty, okay? So since we are not going to tag any column that we put over there, R will automatically put a name over there. So you see, when you are good with the principles of what you are doing, you can predict what will happen. Okay, now we go and create the data frame of, I guess it was 3 rows and 4 columns. Yeah, I hope I'm right. Okay, we start from here. df data frame equal data dot frame, and I'm gonna put the values directly here. Now I'm going to put the first column. First column we put it 1, 2, and 3, and like that we continue. Okay, as you can see, the easy implementation of the syntax over there. You know vectors, and now here the first column, second column, third column, and fourth column, and you see each of them has 3 elements. That makes it 3 rows. So when I ran it, and after that we have df, so we get it like this. Now we have a data frame of 3 rows and 4 columns, and as you can see, my friends, the column names is weird. Okay, so we are gonna tag them to see about the results. Okay, now I tagged them the same way we tagged in list and named the columns as column 1, column 2, and column 3. And you see how much the syntax is understandable. So I'm going to run it another time. And after that, df. And now it is our beautiful data frame. 3 rows and 4 columns. And finally, the structure of this data frame.